Ever wonder how those web apps you use fetch data and update so seamlessly in real time?
It's incredible, right?
Yeah. Today, we'll take a deep dive into the magic behind dynamic web experiences.
Focusing on three key players.
React, Axios, and the power of HTTP caching.
A powerful trio,
Absolutely. We've got some great sources to guide us.
laying out the blueprint for building these amazing interactive experiences.
First up, we'll tackle React's component structure, specifically class components.
Yes, the building
I
blocks.
know, I know. They're becoming less common with the rise of function components and hooks.
Right, right.
But understanding them is like building a solid foundation.
It is. It is. It's like learning the fundamentals before you jump into the advanced stuff.
Exactly. Gives you a deeper understanding of how things work under the hood.
Exactly.
So the sources describe these class components as blueprints for interactive UI elements.
They are. They take in data as props and manage their own internal data as state, which can change over time, making them dynamic and responsive.
And to control how these components behave at different stages, React provides these things called lifecycle methods.
Right, from the moment a component mounts on the page to when it updates and finally when it unmounts.
Speaking of lifecycle methods, I noticed something interesting in the sources.
What's that?
Some of them have been flagged as unsafe and even renamed with these ominous unsafe prefixes.
Oh, yeah. What's the story there?
Well, React is constantly evolving, and features like Suspense, which allows for smoother loading experiences, can clash with those older lifecycle methods.
So it's about keeping up with the latest and greatest,
It is. Relying on those unsafe methods could lead to unexpected behavior.
especially when dealing with all the asynchronous stuff happening behind the scenes.
Exactly.
So it's like React is saying, hey, we're moving towards a brighter future, and these older methods might not be the best tools for the job anymore.
That's a great way to put it. Though understanding them is still valuable, even if React recommends function components and hooks for new projects. Right, like knowing your history so you don't repeat the same mistakes.
Exactly.
Now, let's shift gears and talk about Axios.
Axios, a true workhorse in the world of web development,
It's a JavaScript library for making API requests.
simplifying that communication between our React app and the vast world of data out there.
Exactly. And it seems like Axios is all about making those interactions smooth and painless.
It is. It acts as a reliable messenger, fetching data from APIs without getting bogged down in the complexities of raw HTTP requests,
So instead of our app just sitting there twiddling its thumbs waiting for a response.
which can make things feel slow and clunky.
Exactly. Axios uses these things called promises to handle the whole process.
Right. Promises essentially say, hey, I'll get you that data eventually. In the meantime, you go ahead and do your thing.
It's like ordering takeout. You don't just stand at the counter staring at the kitchen. You go about your business until your food is ready.
I like that analogy.
And Axios goes even further with features like setting up an instance with default settings.
Super handy for streamlining your code.
It's like setting up a pre-addressed stamped envelope for all your API communications. No need to write out the same information repeatedly.
I see what you did there. And then we have these things called interceptors.
Oh, yeah, interceptors. They sound powerful.
They are. They act like middlemen for your requests and responses.
So, like a bouncer at a club who can check IDs and decide who gets in and who doesn't.
Kind of. They give you fine-grained control over the whole request-response cycle, allowing you to modify things on the fly.
That's amazing. So we can use them to log requests, add authorization headers, or even handle errors gracefully.
Precisely. And speaking of error handling,
Yes, because things don't always go as planned in the world of web development.
you got that right. But Axios has got our back.
It provides ways to catch and respond to those inevitable errors that occur during API requests.
Think of it like having a safety net for your data fetching.
So instead of our app crashing and burning if an API request fails.
You can catch the error, display a user-friendly message, or even retry the request.
Now that's robust. All right, let's shift gears one last time.
Time for the grand finale.
Kind of. We're entering the world of HTTP caching.
The secret weapon for making web experiences lightning fast.
It's all about storing copies of server responses so we don't have to keep fetching the same data over and over again.
Imagine loading web pages instantly.
That would be a dream.
It's a dream that HTTP caching helps make a reality.
Okay, so the sources talk about fresh and stale responses.
Right. A fresh response is valid and can be used straight from the cache.
And a stale one means it's expired and needs to be revalidated.
Exactly. And the cache control header plays a big role here, dictating how long a response can be considered fresh.
So it's like a set of instructions from the server telling the browser how to handle the cached response,
Precisely. And then we have these validation tools like eTag and last modified headers.
which act like fingerprints for a resource.
If a cached response is stale, the browser can use these headers to check with the server if the content is actually changed.
So if the server says, nope, it's still the same, the browser can just use its cached copy.
Saving bandwidth and making the page load even faster.
That's brilliant.
And then there's the very header, which allows for more nuanced caching.
Oh, how so?
It lets the server tell the cache to store responses differently based on things like the user's language preferences.
Ah, so everyone gets the right version of the content.
Exactly.
Now, I know sometimes developers might be tempted to just disable caching altogether.
Especially for content that needs to be super up to date.
Right. And you could use the no store directive for that.
You could, but it's like using a sledgehammer to crack a nut.
Meaning there are more subtle ways to handle it.
Exactly. Using no store completely bypasses useful features like the browser's back-forward cache, making navigation slower.
So it's about finding the right balance.
Always. Directives like no cache and private offer more control over caching behavior without resorting to those extreme measures.
So we've covered a lot of ground here, from React class components and Axios to the intricacies of HTTP caching.
A whirlwind tour of dynamic web technologies.
But there's always more to explore, right?
Always. The world of web development is a constantly evolving landscape, and there are even more specialized tools that build upon these foundational concepts.
Tools that can make managing data in our applications even easier and more efficient.
Exactly. And that's something we can delve into another time.
Sounds like a plan.
Those dynamic web apps, they sure rely on a lot of moving parts.
Right. It's like a symphony of components, API calls, and caching mechanisms all working in harmony.
And at the heart of it all, we have those React components.
Right, those class components with their lifecycle methods controlling how they behave at different stages.
Like a set of instructions for each stage of a component's life.
The sources mention the constructor as the first lifecycle method we encounter.
It's like setting the stage before the curtain even rises.
Okay, and traditionally it was the place to initialize a component's state and bind event handlers.
Yeah, that was the go-to approach.
But the sources also mention that with modern JavaScript and things like class fields,
Oh yeah, the landscape has shifted a bit.
we can often define state directly, making the constructor less essential for that specific task.
Right. It streamlines things.
But it still plays a crucial role, especially when working with older code or needing to perform specific setup tasks.
Exactly. It's still an important part of the life cycle.
The sources emphasize calling superprops inside the constructor.
Oh, that's crucial.
What happens if you skip that step?
You break the chain of inheritance, and your component wouldn't have access to those essential props passed down from its parent.
Ah, so it's like missing a vital piece of the puzzle.
Precisely.
Once the component is ready to be displayed, we hit the render method.
The heart of a React component.
This one seems pretty straightforward. It determines what the user actually sees on the screen.
It's all about transforming data and state into those visual elements that make up the user interface.
The sources stress that render should be a pure function, meaning it shouldn't have any side effects.
Right, no messing around with fetching data or manipulating the DOM directly in there.
Keep it clean and focused.
Exactly. Separation of concerns makes our components more predictable and easier to test.
Speaking of other lifecycle methods, we have component didMount, which runs after a component has been added to the screen.
That's our cue to start fetching data from an API or setting up any subscriptions.
Ah, because at this point, we have access to the DOM.
Right. We can interact with the real world, so to speak.
But the sources also mention the importance of cleanup.
Ah, yes. If we initiate something in component didMount, like a timer or a subscription,
We need to make sure to clean up after ourselves in component will unmount
it's like being a good guest, you clean up before you leave.
and prevent those pesky memory leaks.
Exactly. Now, what about when a component needs to update based on changes to its props or state?
We have component didUpdate for that, right?
You got it. It's called after a component has re-rendered with new data, giving us a chance to react to those changes.
React to those changes in component didUpdate. That's a nice little bit of recursion there.
Hee, I see what you did there. But seriously, it's important to compare previous and current values within component didUpdate.
To avoid those infinite loops.
Exactly. We don't want our apps spinning out of control.
It's like checking your surroundings before making a move, making sure you're not reacting to something that's already happened.
That's a great way to put it. So we've covered mounting, updating, and cleanup.
Are there any other life cycle methods lurking in the shadows?
There are a few others, but they've been marked as potentially dangerous.
Like those unsafe life cycle methods we talked about earlier.
Exactly. Methods like unsafe component will mount, unsafe component will receive props, and unsafe component will update.
React is giving us a clear warning sign with those names.
They can cause issues with React's newer features, especially those related to asynchronous rendering.
It's like venturing into uncharted territory. You might encounter unexpected obstacles.
React strongly advises against using those in new projects and provides safer alternatives.
So it's best to stick to the well-trodden path.
Exactly. Now let's talk about error handling, which is closely tied to those API interactions.
Right, because in the real world, things don't always go according to plan.
Absolutely. Servers can go down, network connections can be flaky, or the API itself might return an error.
So we need to be prepared for those rainy days.
Exactly. And Axios provides the tools to handle those situations gracefully.
The sources mention using the .catch method on promises.
Promises, those little bundles of potential.
And the .catch method lets us handle any errors that might occur.
It's like having a backup plan.
So if something goes wrong, we can log the error, display a friendly message to the user, or even try the request again.
And for a more global approach, we have Axios interceptors.
Those middlemen we talked about earlier.
Exactly. With response interceptors, we can catch errors at a higher level, applying consistent error handling logic across the entire app.
So it's like having a dedicated team to handle any issues that might arise.
Precisely. Now let's zoom in on React-specific error handling.
The sources mention something called error boundaries.
Ah, yes. These are special components designed to catch errors that occur during rendering.
So they're like safety nets within our component tree.
Exactly. If an error occurs within a component wrapped by an error boundary,
It's contained within that boundary, preventing the whole app from crashing.
you got it. And instead of showing a blank screen, the error boundary can display a fallback UI.
So the user experience isn't completely disrupted.
It's all about providing a smooth and graceful experience, even when things go wrong behind the scenes.
Now, shifting gears to another performance-related topic,
What's next on our agenda?
data caching. The sources delve into different ways to implement caching in React applications.
Caching, it's like magic, making things appear instantly,
It's all about storing copies of data so we don't have to fetch them repeatedly.
like having a library of frequently accessed information right at our fingertips.
The sources mention in-memory caching and stale while revalidate as common approaches.
In-memory caching is like keeping frequently used items on a shelf for quick access.
And stale while revalidate is like serving a dish while you prepare a fresh batch in the background.
You're on a roll with these analogies today.
Hey, thanks. But seriously, it's about balancing speed and freshness.
Exactly.
But how do we ensure that cached data doesn't become stale and outdated over time?
We have cache invalidation for that.
Cache invalidation sounds like a spring cleaning for our data.
You could say that. It's the process of removing or updating outdated entries from the cache.
And there are different ways to handle that.
Right. We have time-based, event-driven, and key-based invalidation.
Choosing the right approach depends on the specific needs of our application.
Exactly. Now let's zoom in on a specific aspect of caching.
HTTP caching, right?
You got it. It leverages the power of the HTTP protocol to make web browsing faster and more efficient.
The sources mention different types of caches involved: private, shared, proxy, and managed.
Private caches are like personal stashes of data for each user.
And shared caches are like communal libraries of frequently accessed resources.
Proxy caches act as intermediaries, storing content closer to users.
And managed caches give us more control over caching strategies.
They all work together to optimize content delivery across the web.
The sources highlight the concept of freshness when it comes to cached responses.
Freshness determines whether a cached response can be used directly or needs to be revalidated.
And the cache control header plays a key role in setting the freshness rules.
It's like a set of instructions from the server to the cache.
But what happens when a cached response expires?
We have validation mechanisms to handle that.
Validation, so it's like double checking before using an expired coupon.
Kinda. The cache can check with the server if the content has changed using conditional requests.
And if it hasn't, the server can respond with a 304 not modified status.
Saving precious bandwidth.
The sources also talk about the vary header.
The vary header adds another layer of nuance to caching.
Ah.
It allows the server to say, hey, this response might vary depending on certain request headers.
So we can cache different versions of a resource based on things like the user's language.
Exactly. It's all about delivering the right content to the right user.
Now, we talked about cache busting earlier, where we give updated resources unique URLs.
Right, to ensure users always get the latest version.
And the sources mention the immutable directive, which seems relevant to this technique.
The immutable directive tells the cache that a resource at a specific URL will never change.
So cache it for as long as you want, no need to check for updates.
Exactly. It's like saying this information is set in stone,
Now, some developers might be tempted to just disable caching completely,
especially for content that needs to be super fresh.
and they could use the no store directive for that.
They could, but it comes with trade-offs.
It disables helpful features like the back-forward cache, making navigation slower.
So it's a bit of a drastic measure.
The sources recommend more nuanced approaches with directives like no cache and private.
It's about choosing the right caching strategy for this situation.
We've covered a lot of ground here, exploring the depths of React, Axios, and HTTP caching.
But there's always more to discover.
The sources hint at even more specialized tools like React Query, which can further streamline data management in React applications.
And that's a topic for another deep dive. React Query, you say? Sounds intriguing.
Right. It's like this whole other level of data management for React apps.
It's like a specialized toolkit built on top of those core concepts we've been exploring.
Fetching, caching, updating.
Essential ingredients of a dynamic web app.
The sources describe it as a data concierge.
A concierge for your data. I like that.
Yeah.
Taking care of all those tedious tasks.
So instead of writing all that boilerplate code ourselves for every API interaction,
React Query steps in and says, leave it to me. I'll handle the details.
it's like having a personal assistant who anticipates your needs and keeps everything running smoothly.
Exactly. And React Query goes beyond just fetching and caching.
Oh. What else does it bring to the table?
Automatic background updates to keep your data fresh, optimistic updates to make the UI feel super snappy, and pagination for those massive data sets.
Wow, it sounds like a real game changer.
It is. It streamlines the whole data management process, freeing you to focus on building amazing user experiences.
So it's like upgrading from a manual transmission to a self-driving car.
Haha, that's a great analogy. You're in control, but the car handles all the low-level stuff.
Now, we've been deep in the world of React, but I think it's worth noting
What's that?
that those core concepts we've been talking about, API interactions, caching, error handling,
They're not limited to React.
right, they apply to web development in general.
Absolutely. Whether you're working with Vue.js, Angular, or even plain JavaScript.
These principles are fundamental for building any modern web application.
It's like learning the rules of the road before you start driving.
Once you understand the core concepts, you can apply them to any vehicle.
A great way to put it.
Yeah.
So as we wrap up this deep dive,
We've explored a lot of territory.
from the building blocks of React components to the intricate world of HTTP caching,
Hopefully you've gained some valuable insights and a deeper appreciation for the complexity and artistry of web development.
it's a constantly evolving field full of challenges and opportunities.
And as we continue to push the boundaries of what's possible in the digital realm,
Remember to embrace continuous learning and explore new tools and techniques,
that's the key to staying ahead of the curve.
and creating those amazing web experiences that users love.
Until next time, happy coding.